Okay, it's 6:05. We can wait maybe 2 more minutes in case people are still joining. I only see three people in the chat so far. Am I audible to everyone? You can just indicate with thumbs up or write in the chat. Am I audible? Hello. Okay, great. So I think, yeah, people are joining. So maybe we can start the thing and people can keep joining, and that will be better. Okay. So let me just turn my camera on. Okay, hello everyone. Hi everyone. Welcome back to the problem solving session for this NPTEL course, so Joy of Computing Using Python. And this is actually the 12th and final class of this course, or I mean, the final class of this problem solving sessions for this course. So by now you know the drill, but yeah, because hopefully you have joined for at least a few of these classes. But yeah, my name is Zenia. I am an astrophysics PhD from IISc. And, over the last few weeks, what we have been doing together is solving some problems and doing some programming live in this 2 hour session so that you are better equipped to, handle more questions for your assignments and your exams. So yeah, as I said, this is the last class. Thanks a lot for joining, and I think we can just go for the session as usual. So in the 12th week lectures, you saw final week of lectures. You saw two main kinds of programs, which was this page rank algorithm, which is actually partly what Google uses to rank web pages according to their order of importance. So when you search in Google, there is so many results, and the way that they filter or they sort those results is through this page rank algorithm. And you can also implement that on your networks and graphs as you saw in your lectures. We also saw a famous mathematical problem or a mathematics problem, which is still an open problem called the Collatz conjecture, where you actually are applying a set of instructions to certain numbers and seeing if all natural numbers will eventually end up to give a chain that ends in 1. So this is still something that has not been proven, and this is still an open problem in mathematics. You saw how to do a Python implementation of the same. So this just shows you, just in this 1 week of lectures, you have seen two very different problems. And I think that throughout this course, the diversity of the problems that you have solved or that you have seen just shows you what a powerful tool programming is, and specifically what a powerful tool Python is, because you can see how all different kinds of programs and all different kinds of problems are actually being tackled by Python. Okay. So I've been using this slide in all of my course classes because it's important. I think you should have good coding practices, and I hope that you have been implementing some good coding practices and will continue to do so even after this course. Remember to try to use this course as kind of like a jumping off point. That would be a good idea. So this is about the PageRank algorithm. Just to remind you, PageRank was one of the algorithms by Google that determines how the relative importance of pages within the internet. So for this, it looks at the quantity and quality of other pages that link to it. And then it assigns a value depending on the backlinks. So basically, a page rank is given based on how many other pages link to that page. So more pages are linking to that page means it must be somewhat of a primary source, right? So that's how you determine the page rank. Of course, that's a very simplified way of describing this algorithm. And I think right now Google doesn't just use this algorithm, it has more sophisticated ones as well. But in general, this is a very nice way in which you can tackle this problem of sorting websites. Collatz conjecture, as I said, is an open problem in mathematics. I'm just showing these slides to remind you guys. So for example, this is the algorithm. You have to, if you get an even number, you divide it by 2. If you get an odd number, you have to do 3x plus 1. There is a very nice Veritasium video on it. It's around 23 30 minutes. If you guys are interested in this sort of thing, I would really recommend this. I have also linked it in the slides. I'm not playing it now, but in your own free time, when if you are interested in this sort of thing, I would really recommend watching this video. He explains the problem very well. So as you can see, this is one such chain which eventually ends up as one. So the question is that if all numbers, do all positive numbers actually converge to one eventually, and this is still an unsolved problem in mathematics. So people have been computing it for larger and larger chains, but of course it is, there is no generic proof yet which is true for all numbers, which is why it's a collage conjecture and it's not really a theorem because it's still not proven. Okay, and yeah, as I said, if you guys, any of you are very fond of math and open problems, I think this is an interesting subject. I would really recommend that you watch this video. Okay. Yes. Okay. Sorry. Yeah, it's 20 minutes long. We'll just skip it for now. I've linked it in the slide. Okay. Anyway, so that was just a recap of the things that you saw in this class. So as usual, let's do our usual MCQs first, and then we'll go to the programming. I can see that there are a few of you who have joined. So please put your answers in the chat, and we can discuss them in due time. Okay. So this is the first question. Which of the following is not a factor which is considered in Google's current search algorithms? So you have four options. Please put your answers in the chat. Okay. One person says A, others. Any other answers? Okay. B. Okay. I can see one more person saying A. Any other answers? Or uh, okay, maybe we can go to the answer. Any other answers? I don't see any other answers in the chat. Let me just check here in case it's not updated. No. Okay, so the answer is actually D. Okay, so I don't think we know exactly what is Google's current search algorithm. I don't think they make that public. But the point is that, of course, they don't solely use page rank anymore, but it is a factor. Along with that, they do put in some feedback from the users and content relevance. This is all part of it. So the point is that Google does not just use one algorithm anymore, like the page rank, which they used to do in earlier days, but right now their algorithm has become more complex to take care of other factors as well. So the point is that the question was which is not a factor which is considered in Google's current search algorithms. So all of these are somewhat part of the algorithm. So that is the idea. Okay, is that fine for everyone? I think you understand, right? It's more complicated than just using PageRank or just using one of them. Okay, I think we can go to the next question. If you guys have any doubts, please put it in the chat or you can unmute. But for now, I'm going to the next question. Okay, so in a weighted social network graph, so again, you have learned about graphs and networks using Network X module. What might the edge weights represent? So suppose you want to draw a graph of social networks or basically the relationships between people, then what could the edge weights represent? Again, you have four options. Please put your answers in the chat and we can discuss. These aren't like your usual programming or calculation based questions. So please try to answer quickly. Okay, one person says D. Any other answers in the chat? I only see one answer in the chat. Come on, others. Okay, one more person says D. Any other answers? Okay, I guess we can move to the answer. Others also please answer. Point of these sessions is to be interactive, and this is the last session. Might as well answer today. So the answer is, oh, sorry. I went back by mistake. The answer is actually D. So you guys are correct. It's all of the above. So it depends, right? All of these are kinds of interactions between people, and you can always, it depends on what is the exact thing that you want to graph. But all of these could be valid as edge weights, that basically the line connecting two users. Okay, next question. What is the purpose of random walk in graph analysis? This time I want at least more than two of you to answer. I think I can see more people are there. So please, all of you try to give an answer. It'll be good. Okay, one person says B, others. Okay, one more person says B, others. Others, at least one more person answer. Any other answers? Okay, I guess not. Please make it interactive, guys, as much as possible. The answer is actually B. So with the random walk, you're trying to, hit all the positions in the graph instead of just going from one end to another end, which might take time. You just try to do a random sampling to hit as many points as possible. That's what random walks does. Okay, so this is a multiple select question. This is the next question. Which of the following are real world applications of directed graphs? So this is a multiple select question, which means multiple options could be correct. Okay, one person says D. Others also please interact and answer. Okay, one person says all of them. Okay, someone says A. A, C, D. Okay. Any other options from anyone? Any other answers from anyone? Okay, I don't see anyone else answering. I can go to the answer. The answer is actually B, C, and D. Okay, to understand this, please check that this question does not ask you which are the examples of graphs. All of these are examples of graphs, but it instead asks you about what is the application of a directed graph, right? So why is a social media friendship graph not directed? Because there is no direction like A is friends with B and B is not friends with A, right? It's always A and B are friends with each other. For example, B and C are friends with each other. So there is no sense of a direction there. Whereas when you go to a family tree, for example, there is a clear direction. A father and then a son and then grandson or whatever it is, right? Grandfather, father, son. It has to be in that direction. It cannot be in another direction, right? So that is why family tree is definitely a directed graph. Similarly, website. One website may link to another, but the other website may not link back. Similarly, airline routes also, you might go from A to B and then B to C. That is different from going from B to A, right? So those are different. So that's why the direction matters. Does anyone know what this problem is? I don't know how to pronounce this, but probably it's Konigsberg bridge problem. Does anyone know what that is? Okay, yeah, okay, fine. Puzzle. Yeah, it's a type of, it's again a mathematical problem. Maybe I can just show you guys. Sorry about that. Let me just show you on my screen. Yeah. So basically, it's about, you can see it here. It's an old problem considering the possibility of walking a path over all seven bridges, which is over this particular island called Konigsberg. So this is also a network because you have to, again, connect these. But again, walking bridge does not matter if I walk over the bridge in this way or that way. I just need to cross the bridge, right? So in that sense, this is also not a directed graph. So the idea here is that just going back to the question, the idea here is that this word of directed is very important when we consider. All of these are examples of graphs, of course, but they are not directed graphs. I mean, A and E are not directed graphs. Okay, I hope that clears it up for you. We can go to the next question. Please, more of you answer. I always see that the same two people are answering and everyone else is keeping quiet. Please try to answer. These sessions are held, this is the last session. The session is held so that you can interact with me and we can clear your doubts now itself so that it doesn't go ahead. Okay. Okay. Next question is numerical answer type. So the answer is a number. So it says read the given code which is given here. Enter the number of elements in this in this variable incoming edge is D. Okay. So this is a number. So read the code and give the answer in the form of a number. And please, more of you answer this time. So this is based on Network X, which you have already seen is a Python module that helps you to draw these networks and graphs, which we have discussed in this class, but also in some previous classes. I don't see any answers yet. Any answers in the chat? Okay, one person says 3. Any other answers? Any other answers? Anyone else? Any other answers? Okay, please try to answer, guys. If you're having difficulty, I'll just show the answer for now so we can finish. So here, as you can see, the answer is actually 2, not 3. So here we need to show what are the incoming edges. Okay, so be very careful with incoming edges, because as you can see, there are only two edges which are incoming to D. So B goes to D and C goes to D. Here also D is involved, but D is incoming to E. This is an outgoing edge from D. So that's why the answer is 2 and not 3. Does anyone understand? So there are two kinds of, for example, if I show you a network, let's try to look at this. So this is a network, right? So here you can see that, for example, for F, right? F has one incoming edge and it has one outgoing edge. So it does not have two incoming edges. Only one is going towards F and one is leaving F. That's why one incoming edge and one outgoing edge. So that's how you have to think about it. Similarly, in this network, which is given here, you can see that B goes to D and C goes to D. So there are two incoming edges. D goes to E is an outgoing edge when we look at the node D. Okay, does everyone understand this? Does everyone understand this? Okay, great. So let's go to the next question. Which of the following statements about page rank is true? Okay, all web pages start with initial page rank score. One person says B, others. Hello, is there a question? Okay, I think that was by mistake. Yeah, okay, one more person says B. Any other answers? Okay, I think we can go to the answer. The answer is actually B. So all pages start with the initial page rank score, and then the algorithm determines if they should be weighted more or weighted less, as I said, based on the links that are linking to it and so on. Okay. Next question. In the collage sequence, if starting value is a power of 2, how many iterations are needed to reach the cycle 4 to 1? So again, just to remind you, guys, this is the conjecture or collage sequence. So when you get even number, you divide by 2. When you get odd number, you multiply by 3 and add 1. Okay, so let's go back to the question. Sorry. I went too far. Yeah, this is the question. In the collage sequence, if starting value is a power of 2, how many iterations are needed to reach this? Okay, one person says B. Any other answers? Any other answers in the chat? Okay, one person says A. Any other answers, guys? Okay, please interact. I'm asking again. I always see the same few people answering. The answer is actually B, because as you can see, we are starting with a power of 2. So that means that we are going to divide by 2 means we are just basically going through the powers of 2, right? For example, if we start with 32, then that's going to go to 16, 8, and then 4, 2, 1. Of course, if we start with something bigger like 1024, that's going to go to 5, 12, 256, 128, so on, right? So basically it grows as the exponent, and the way to get the exponent is of course the logarithm. So that's why the number of iterations is logarithmic in the size of the starting value. Like for 8 you need only one iteration to reach 4 to 1, whereas for 32 you need couple more, you need two more iterations, because 8 is 2 cube and 32 is 2 power 5. So there is a difference of 2 in the logarithm, right? So it is the logarithmic value which matters here, because we are worried about the power. Okay, does this make sense to everybody? Does this make sense to everybody? Okay, please let me know if you are finding any difficulties. And I'm going to the next question. More of you try to answer, it will be good. Next question, how many positive integers below 200 does the Collatz sequence not reach 1? So please put your answers in the chat. Okay, I see one person saying A. A. Any other answers by others? Only 5 of you are in the meeting. I think all of you can answer, right? I can wait for you guys. I'll wait maybe a minute or something and I'll answer. Show the answer. Okay, yeah, okay, fine. I can go to the solution now. I don't see anyone else answering. The answer is actually A. That makes sense because, as I said previously, this is still a Collatz conjecture. It's not yet a theorem because, we still don't know if it can be generalized to all numbers or not. Of course, if any of the numbers below 200 had not given 1, we would have immediately known it's a false theorem or it's a false statement. But the fact that can go up to not arbitrarily, pretty high numbers and still not know, we are not able to generalize is the issue. So we have checked for lower numbers. The idea is that we need to generalize for higher numbers in order for this to be actually a theorem. So there is no generic proof of this conjecture, and that's why it remains still a conjecture. Okay, so next question. Which of the following is true about the Collatz conjecture? So I think I have given the answer just now when I explained. So I want everyone to answer this question. So I hope all of you are listening. I want everyone to answer this. Okay, one person says C. Any other answers? It will be good if everyone can answer the question because only few of you are there in the meeting. So I can wait for all of you to answer. Any other, at least one more person answer then. Okay, fine. One more person has answered. So the question answer is actually what I had actually just said before as an explanation of the previous question, which is that the Collatz conjecture, as the name suggests, is still a conjecture. It's not a theorem because it's an open problem whose status is unknown. I hope all of you are listening because I had just given the answer of this question and yet most of you had not answered the question. That's kind of disappointing. Please try to listen and interact. As I said, that's why these live sessions are held. Otherwise, these can also be recorded and uploaded on the portal, and you can watch them like you watch the other lectures, right? The whole point is that you guys can interact and discuss when we do these questions. Okay, next question is numerical answer type question. Find the number of sequences required for Collard's conjecture when applied to 5 to reach 1. So I had already shown the definition of the Collard's conjecture before, so I'm not going to show it this time. I want you guys to try it out and do it yourself. Okay, so the answer is a number. The number is the number of sequences or number of steps that you need to reach 1 when you have the Collard's conjecture. Okay, one person says 5. Others, any other answers? Okay, one more person says 5. Can one more person answer this? Because I always see always the two same people who are answering every question. So I'll wait for one more person to answer. Okay, I don't see anyone else interacting. That's very disappointing. But yeah, the answer is actually 5. Good job, the people who did answer. So this is actually the sequence. If any of you had worked it out, it's basically 5, 3x plus 1 is 16. Then it just goes to 8, 4, 2, 1 because 16 is an even number and it's also a power of 2. So you can see that there's 1, 2, 3, 4, 5 steps that are required for 5 to reach 1 when we apply the Collard's conjecture. Okay, I think the questions this week are very straightforward. So kind of disappointing that most of you didn't answer, but it's fine. So now let's try to do some programming assignments. Please, I'll give you a few minutes to try it out and then we can discuss the solution. Please, again and again, as every class I say, please actually try doing the solution. If you don't get it, it's fine. We are going to discuss the solution anyway, but please try it at least because that will help you to think about problems. These are new problems to you, so it's always good to have more and more problems because programming is a skill that can only be improved through practice, right? So please try to at least, even if you don't write it, the syntax correctly, try to get the logic, right? Syntax you will get with practice, but logic you have to learn how to see a problem and immediately get the logic. So here is the first question, okay? So first question is about this thing called the Pearson correlation coefficient, which is basically it's a statistical quantity which measures the correlation or the association between two sets of data. For example, you can see in this problem, the data is in two lists, X and Y, and this is the formula for computing. So if any of you are unfamiliar, this X with bar on top is the mean of X. Okay, and Xi is an element of the list X. X with bar on top is the mean of the entire list. So x and y are lists. Xi refers to a single element in the list, and x bar or y bar refers to mean of each of the lists. And here you can see that there is a summation over all the elements of the list. That's what this means. So this is the formula for the Pearson correlation coefficient. Here xi corresponds to element x of 0 in the list x. We have used zero indexing here. So not exactly 0, it should be, sorry. So this is wrong, it should be x of I. Yeah. So xi is basically x of I, where we have used zero indexing because we are doing Python, of course. So write a function named Pearson that accepts these two lists x and y as arguments and returns the Pearson correlation coefficients between them. To make things simpler, write separate functions for repeated actions in the formula. And this is a good idea to have whenever you have some complicated formula or a complicated function. You'll often find that there are lots of repeated actions, right? So you can always write separate functions for those repeated actions and call them. So try doing it in that way instead of just repeating the same block of code over and over in your function. A more friendly way or a user friendly way, and also a better way to do it, is to take those repeated blocks of code and put them in their own function. So that is what has been suggested here, and that's what you should do. To give you some more insight into the Pearson correlation coefficient, basically it is a measure of how closely connected two things are, right? So for example, you can see that this list X and list Y, if both the points are, related in a way that they form on a straight line with a positive slope, that is a positive correlation. Whereas if they fall in a line which has a negative slope, that's a perfect negative correlation. Most things are somewhat they will be perfectly -1 or 1, they will be somewhat in between, right? So if something has a correlation coefficient of 0.6, that means it is mostly, positively correlated. If one increases, the other one also 60% increases. Whereas here this is like, if one increases, the other also increases for 100% of the time. That is how you think about it. Of course, if you have a random sample where there is no trend between the points, that's when you get zero correlation. None of them are related to each other. So that is what this correlation coefficient is actually measuring. It's a good idea because it gives us how much things influence each other, right? We might have two set of data and we want to know how much are they actually influencing each other. For that, we have to use something like this. Okay. So and this is the formula again. I'll give you maybe 10 minutes and we can discuss after that. But please, all of you, try to write this program and give some simple values, like you can give 200% correlated cases like 1 2 3 4 5, and then 2 4 6 8 10. Those are perfectly correlated, right? They are one, it's just y is equal to 2x. So you can do that and check if it is giving you a correlation coefficient of 1. Similarly, you can give a correlation, negative, perfectly negatively correlated case. Then you can try giving some random numbers and see. Mostly, even the random numbers will show you some correlation in between. But yeah, the point is for you to try this out. So I'll give you 10 minutes. Please try it out and we can discuss the solution after that. I don't know what that was about. Are you guys working on it? Please raise your hand if you're working on the problem. Or none of you are working on it? Is nobody working on this problem? Is there any doubts? Do you not understand what you have to do? If you want, I can explain this question again. Is there any doubts? Are any of you working on it?
Hello, can
Yeah,
you hear me?
please.
Yeah.
Yes, yes, tell.
Madam, what is that X bar and Y bar? Is it average, ma'am?
Yes, yes, yes. That's what I was
Okay,
saying. So
because
X
I
and
joined later.
yeah. X bar is the average of the list X and Y bar is the average of the list Y.
Okay,
And the Xi is one of the elements. Xi is
okay, okay,
ith element.
okay. We should write separate function for all this thing, huh?
Write one function called Pearson, and then you
Okay.
have these like, repeated things like mean, you have a
Uh,
repeated square. You can write separate function for that. It will
and
make
I
the
can
whole
call.
thing easier. Yeah. And then you
Okay,
can.
okay, okay, okay.
Okay, I'll discuss the solution in 5 minutes. I'll give you a chance to try to do it first. We can discuss. Okay, maybe we can go to the solution. So again, let's take the program. Okay, let me just. So, as I said, or as the program said, we have all these repeated actions in the function, right? This is the Pearson function. You can see that there is this repeated action where we have to take the mean, that we can write a function easily. But we are not really only taking the mean. The mean is always coming in this combination of xi minus x, which is basically each element minus the mean. We have to calculate how much each element is different from the mean. So we can write a function which actually takes care of this combination, because it's this combination which is actually coming everywhere. Similarly, we have this thing where we have to multiply two elements of a list together. So here when it says I equal to 0 to n minus 1, this is a summation, right? So this means that we have to start from 0. So the zeroth element, or the first element, because we are using zero indexing, so it will be x0 minus x bar into y0 minus y bar plus x1 minus x bar into y1 minus y bar. So we have to first multiply two elements together and then we have to add them up. So there is here also, if you think about it, if when we are squaring, we are just multiplying this thing with a copy of itself. Similarly, here also we are multiplying by a copy of itself. So again, here we have x1 minus x bar into x1 minus x bar, y1 minus y bar into y1 minus y bar. So these are all repeated things. So far we have identified two repeated actions. One is this combination of calculating the difference between each element and the mean of the list. For that, we can write a function. The other repeated action is, of course, multiplying two elements of a list together and then adding them up, right? So we want something like P1 Q1 plus P2 Q2 plus P3 Q3, but P1 Q1 etc. are these kind of combination of x1 minus x bar. Does everyone understand this? So first we are trying to, right now what I'm trying to do is I am trying to identify which are the repeated functions or repeated actions which are there in this Pearson coefficient. What you'll find is when you do programming, or when you do try to apply programming to many complicated problems, there might be these actions which are repeatedly there, and you might just be copy pasting the same snippet of code everywhere. Instead of that, you can put it into a function and you can just call that function. That is much more efficient in that way, right? It makes the code also more concise and you can understand actually what's happening. So that's why this hint is given to you, that write separate functions for the repeated actions in the formula. So let's try to look at how it is done. So here you can see that we have written a function for calculating xi minus mean of x, which is basically this combination. Of course, not only x, it can be applied to y also. So you can see that for any list, so maybe I can write this as P so that there's no confusion. So yeah, so for any element P, for any list P, the mean will of course be the sum of the list divided by its length. Whereas we want to return a list. So again, for every element, we will get this P minus mean for all the P in P, and that basically this returns a list. Then this is a function for multiplying and then corresponding elements of two lists and summing them up, I should say. So here you can see that we were taking the sum of P of I into Q of I for I in the range of for all the elements. So that is basically taking care of this combination, even the square combinations, right? And finally, you can also write an extra bonus function for just taking the square root. That is not necessary, but it has been done here just to give you an idea. But you can, of course, use the square root functionality itself. But here that has also been done. So here you can see that we are first taking x norm, which is basically the normalized value. Normalized value is basically xi minus x bar. Okay, so you are first using this list to calculate what is xi minus x bar, oh, sorry, and yi minus y bar for all the elements in the list. So you get some normalized list. You get some new list, which is actually all the elements are xi minus x bar and yi minus y bar. After that, what you're doing is you are taking, the numerator. The numerator is what? The numerator is just the multiplication of these two element wise and then summing them up. So that's what you have done here. The numerator is basically just this function with x and y, whereas the denominator is the multiplication of that each list element of the list with itself and then summing it up, and similarly for the other list and then taking the square root. So that's why here you can see that we are multiplying each element with itself and adding it up. So you can see x norm is coming twice, similarly y norm is coming twice, and then overall I'm taking the square root of the whole thing, because you can see that there is a square root function. Okay, so that's how you can return the numerator and the denominator. So as I said before, this Pearson correlation coefficient is, you can better visualize it as thinking of it as how close two observations are to a line of best fit, how easily you can put a line of best fit through them. So here is example of perfect positive correlation where all the elements lie on a line of positive slope, whereas a negative correlation, perfect negative correlation, is all the points lying on a negative slope, right? So usually the values may not be completely perfectly correlated. It might be, so essentially it tells you that when something has a positive correlation, that means when one item increases, the other item also increases. Of course, when there is a positive correlation, when one list element increases, all the other when one list increases by certain value, all the other list items increase by the same value, right? For example, 1 2 3 4 5 and 2 4 6 8 10, they have a very strict relationship, y is equal to 2x. So, but not all lists have to be like that. There may be some lower correlations also. So it generally tells you that if I increase this knob, does the other list also increase or does it decrease? If it decreases, that means they are negatively correlated. If it increases, it means they are positively correlated. It could also be that I increase this knob, or I increase something, I change something of this list and the other list is completely unaffected, in which case we have zero correlation, but usually you will find some relationship between both of them. Okay, so let's try to run this program and see if whatever I said makes sense with respect to the program, right? So let's try to run the program. Let's enter the first example I said, which is 1 2 3 4 5 2 4 6 8 and 10. You can see that they are perfectly positively correlated as we expected. We can also try with can see that they are perfectly negatively correlated. This is just y is equal to minus x. Now let's try to get some random, extremely random numbers and see if we can try to get a negative or a zero correlation. Give me a second. So, okay. So let's give like 0.1, 45, 900, 40, 478. Okay, and the other list can be 40. Let's give something completely different. 0.002, 22, 3000, -1. Okay, somehow they are still quite positively correlated. So I guess I have to give completely random points, then it might be completely uncorrelated. So this is something you can play around with, right? You can calculate. I haven't done the math, but you can actually calculate what would be two lists that give zero correlation and check if they are actually giving you that or not. Okay. So this is about the first program. I hope there aren't any doubts. This is fairly straightforward. It's like just to implement this function, the main takeaway of this is the fact that when you have repeated actions, like you could have written this without, defining this f. Let me close this. You could have written this without defining this f, g, and h. But because we defined f, g, and h, you can see how readable or how neat the Pearson function actually becomes. We are able to understand it much better, right? We can look at it and we can see that, okay, what does g do? G does this. Whereas when we write the whole thing without defining anything else, it will look very messy. It will be very difficult to read. So readability of code is also very important. And of course, when you have repeated actions, makes sense to put them in a function. So you can call it as per your convenience. Okay. So this is the first program. Please try out the programs yourself. This is the last class, and these live sessions are held. And I think the goal of the live session is that you can, try doing some programming live and then see immediately if it's correct or not. It will be a good practice for you. Okay, let's go to the next question. This is also not a very difficult question. It seems like a long question, but when you try to look at it, it's a very simple question only. So let's try to understand. So there's a square metal plate in a 2D space is a setup which you are going to work with. So you can think of the spatial grid. Okay, it's like a graph, right? It's a spatial grid, and you have XY coordinates for all points on the grid. So basically, 0, 0, 0, 1, and so on, like that you can think about it. So there is a basically the grid is having x and y coordinates between 0 and 5. 0 and 5 are included. The temperature at any point xy on the plate is given by the following equation. The temperature is measured in Celsius and can be negative. So you can see there's a function. There is a microorganism which lives on the surface of the metal plate. It occupies only those points where the coordinates are integers. The organism cannot survive in high temperatures and instinctively moves to region of low temperature that are less than or equal to a threshold of T. Okay, so this is the threshold temperature. If no such region, that is, no such region which is below the threshold temperature is found, it can't survive. The terms high and low are used in relative sense, which should be compared with respect to the threshold. So basically, this is an organism where can only survive below some threshold T, that T you are going to supply. And then it's going to check if there are any points on the grid which have a temperature lower than T or not. If it doesn't find any temperatures below T, then it will give false, which is the survival probability. It gives true if the organism can survive on the plate. So this is a kind of a long question, but the gist of it is you need to find out if this organism can survive or not based on your input of the threshold temperature. So please try out this question. I'll give you few minutes. I'll give you 10 minutes. Please try it out. I want everyone to try the question. This is not a difficult question. Please try it out. I hope you guys are trying this question. Please try the question and then we can see. How many of you are trying the question? Please give a hand raise. Is no one trying?
So,
Yeah,
uh,
please.
I have provided that in this thing, chart.
Okay, okay, okay. I didn't see. Let me check. Somehow it has not come up for me. Maybe I'm having some internet issue. So you have got the solution.
I didn't check this thing. I returned the code. I have
Okay, okay, sure. Good. Others also please try. Maybe I'll wait for 2 minutes and then we can discuss the solution.
We'll have another session like for revision.
I'm not conducting any revision session. Maybe some of the other TAs are. You can check with them.
Okay. Thank you.
Yeah. This is my last session.
Madam, is it like exam is postponed or what?
I'm not sure about the exam dates. What was informed to you? Some postponement was informed to you?
No, in the portal it says November 2nd. But
Okay.
today I received a message to my this thing cell number saying that
Uh-huh.
you have to register for the semester exam scheduled on 7th, 8th, 14th, and 15th December.
Oh, okay. I'm not sure then what is the date.
But when
Maybe.
I check the portal, it says still November 2nd.
Okay. Huh. You have to check with them. I'm not sure about this exam things. That is by them. They decide the dates and everything.
Mm.
So maybe you have to check with those people about you can ask in the portal or something about this.
Okay, ma'am. Thank you.
Yeah, sure. Okay, yeah, I can see that your answer has come up for me now. So good. So maybe we can discuss the answer. One of you has given an answer in the chat also. So this is not very difficult. It is just a simple question. It just seems very long. So let's just go to week 12, program 2. So as you can see, this is just the function which they gave in the question for the points at where is my point. So this is the function which determines the temperature at every point x comma y. This is a grid where you can imagine it to be like your graph paper. So 0 0 0 1 0 2 0 3 until 0 5, and then a grid downwards also. So 1 0 1 0 2 0 3 0 etc. It's a matrix or a grid or however you want to visualize it. Every point on the grid has a temperature determined by this function. Okay, so you can see that for the survival, all we are doing is checking for x in the range 6. Again, why is it range 6? Because we have to consider all the numbers from 0 and 5 included. So I can't use range of 5 because range of 5 does not include 5. Similarly, for y in range of whatever. So if whatever function that you have is less than t, then return true. Otherwise, we are returning false. So you are actually going to enter the input to the threshold temperature and then you're going to do. So I think you have done it in a slightly different way because you have said input of x and input of y. But the point here is that we want the input to actually be t, which is the survival temperature. So your program kind of checks whether at a given xy does the organism survive, whereas here the question is you have to check the entire grid so that if there are no regions where t is less than t, then it can't survive. So you have to check for the entire grid,
Okay.
that is from 0 to 5, and then check if At any point is it, if you find even one point where the temperature is less than threshold, it can go there and survive. If you don't find any points, it can't. So you also solved the problem, but you solved a different problem essentially. So please be very careful when you read the question. Anyway, so I think you understand, right? So this is basically, we are giving the threshold and we are checking if this is the threshold, is there any point on the grid? This is the threshold, is there any point on the grid?
That
That's how
means
we are
we have
looking.
to check for all the possible points, right?
Exactly. So that's why we have here, you can see that all the possible x and all the possible y has been checked.
Okay, okay, okay.
Only if all of them are less than t, then only we can return true. So I can just show you a run. And I also wrote this additional small code, which is not really required for your solution, but I just wanted to visualize what are the different temperatures, because we should know if the code is going correctly or not. So that's why this code is there. This is just visualizing what is the actual temperature that this function gives. So let's try to give the temperature to be 10. Okay, so that means that if the organism encounters temperature less than 10, only it can survive. If there is no grid, there is no point on grid which is less than 10, it will not survive. Okay, so let's see what happens. So it gives false, and this is actually the grid. So you can see 0, 1, 2, 3, 4, 5, and then here also 5. And this is actually the grid that you get if you compute this function at all x and y. So you can see that throughout the grid, we only have value. The smallest value is, if I'm not wrong, the smallest value is 25, right? So if I give any
24.
threshold,
24 is there. 24 is there.
24
Yeah,
is, thanks.
20.
I missed that. So 24 is the smallest value. So any value, if the threshold itself is less than 24, it cannot survive for sure. So I just wanted to print the grid to make sure that the program is calculating correctly. It looks like it's calculating correctly. So same way, if I give something like 30, can see that the bug can still, organism can still survive, because all these points like 27, 26, 25, 24, all of them are able to are lower than 30, so it can move to any of those points and it can survive. Okay, so this is how you do this program. This is also, it's quite simple, it's just it's a long question. So these kind of questions, read very carefully, and then you can try to, finally it's just checking one condition, so it's quite simple. But yeah, this is optional, this is not part of the solution. This was just so that we can visualize what is the different temperatures that we have. Okay, so I think we can go to the next question. This is the next question. It's again a stats question. So here we want to write a function called standard deviation, stddev, which accepts a list of real numbers x as the input, and then it should return the standard deviation of the point. Standard deviation is given by this formula. Here xi refers to the element xi, and x bar, which we used in a previous program, x bar is basically the arithmetic mean of the numbers which are in x, right? So here you can see, for example, if any of you don't know, standard deviation is basically how much something is spread, right, from the mean. So how much a distribution is spread from the mean is told by standard deviation. This is just for visualizing, and this is the formula which is used for standard deviation. It's very standard formula which has been used in statistics. So I think it's not very difficult. Again, please try to write a program. I'll give you a few minutes and then we can discuss the solution. I hope you guys are working on it. I'll give you a few more minutes and then we can talk about the solution. Okay, maybe we can go to the solution now. Did any of you try? Okay, fine. I can see that there is a message in the chat. Okay, great. So someone has given the answer already. Let's try to go to the solution now. So I think the code looks correct to me. You can also try with some, yeah, 1, 2, 3, 4. You can try. We can also try the same thing. So yeah,
I
this
got
is a very simple.
2.5, 2.5 as the answer.
Yeah, that should be 1, 2, 3, 4. The mean is 2.5, so the spread might also be. Yeah, let me see. Let's try to compute it here. So here you can see that this is the program. It's very simple. You calculate the mean, and then whatever is your standard deviation is half times the sum divided by n minus one. Okay, so this is the basic thing. So let's try to calculate it. I give comma. Okay, so the answer is actually 1.29. I think I know the thing. It's because in this formula, the value is given here is n minus 1. I think it should be n, right? It should not.
Yeah, should be
N.
N.
I think the question they have given the wrong formula. So yeah, if I give n, I think this will be correct. Let's see. So it seems n. Oh, okay. I think I understand. The value I'm getting is 1.12. Just check once if there is any issue. Has anyone else tried this? What is the value you are getting or something? Hello. Okay, I searched it. One sec. Let me just search this. So I can see that n minus 1 is also used. I think if it's a sample, you have to use n minus 1. So maybe n minus 1 is the correct formula. It says sample size. So I'm not very sure about this, but let's stick with n minus 1 for now. Uh, let's just go back. So if I use n minus 1, I get this value. And if I use n, get the other value. So please, whoever gave the solution, please check once. Maybe you have made some mistake somewhere. Just check it once if there is any issue. Others also, if you have done it, please check. Let's just do a Okay, so when you have not an entire population but only a sample, then you have to use this n minus 1. So let's keep it as sample. So you can see that the answer is 1.58. And if I give 1, 2, 3, 4, it's 1.29. If I keep it as population, then it's n value. Then it's 1.118. So none of them are 2.5. So please check your answer. Like I just use the standard deviation calculator to check if they are correct. So just check if you have made any mistake somewhere, and you can check because this is the value that you should get. 2.5 is actually the mean. So maybe
Okay.
you are, so yeah, you should return something else. Okay, so that's what is the point. Okay. So yeah, there seems to be two formula for the standard deviation. I was also familiar with this n formula, but I guess there is another one. I'm not from statistics background, but yeah, this is an interesting thing. I'll just link this so that when you guys also do it, I hope others are also working on it. So you can see that how working on something gave a issue in the code or something like that. So that's why it's important to try these out. So I'll just link this in the slides so that later if you're referring, you can also go and verify your answer in that place. Okay. So I think just check your answer, and if you don't get it fixed, we can look at the code again. Must be some small mistake. Okay, fine. Let's go to then the last program for today, which is basically a Python program to print Pascal's triangle up to order n when you take n as an input. So does anyone know what is Pascal's triangle? Anybody here who knows what's Pascal's triangle? Okay. If you guys don't know, I'll explain. Pascal's triangle is a pattern in mathematics where this is basically the pattern. Maybe you have seen it before. It's a very interesting pattern. How you form this is basically you start with the row 0 and 1, which is like 1 and 1, 1. Then for all the subsequent rows, you have to take the sum of the two numbers which are above it. So for example, you can see that here, of course, the ending and the starting numbers will be 1, but everything in between is by the sum of the previous row above it. So here you can see that 1 plus 1 is 2. Similarly, if you want to calculate for row 3, then you can see that 1 plus 2 is 3, 2 plus 1 is 3, and then 1 at the end, 1 at the end. Similarly, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and so on. So this is how you generate the entire thing. Okay. So this is Pascal triangle up to row 10. But the program I am asking you to do is you have to print Pascal's triangle up to order n, where n is an input. So generalize it to n, and if possible, this is a bonus. If you figure out how to do this, try to also print it in this triangle pattern with the correct spacing. So you have to give this many spaces so that it comes in a triangle pattern. So this is the program. I'll give you some minutes to figure it out. This is by the way, any of you are more mathematically inclined, you might have come across as a very interesting pattern which has a lot of interesting things. For example, each row gives you the power of 11. Like this is 11 power 0, 11 power 1, 121 is 11 squared, 1331 is 11 cube. So if just by reading of Pascal's triangle, you can get the power of 11, like 11 to the power 9 is this huge number. If we just write all the numbers together, it also is related to combinatorics. So if you know about permutations and combinations, it comes up here. So it's a very interesting mathematical pattern. Okay, but that all is not really relevant right now. If you know the mathematical properties, you can generate the Pascal's triangle using some other ways. Like you can use the fact that it's powers of 11. But for now, let's just use the fact that, each row is generated by summing up the elements of the previous row just above it. So if I want to get 3, it's 1 plus 2. This 10 is because 4 plus 6 is 10. Similarly, 6 plus 4 is 10. Then 4 plus 1 is 5. You start and end with a 1. Okay. This is how you do it. Please try to do it. I'll give you a few minutes and we can solve it. I mean, we can discuss it at maybe after 10 minutes, we can discuss the problem. In case you guys need to be reminded what is Pascal's triangle, I'm just showing it here. Okay, I think we can go to the solution. Let's discuss because time is there. Let's go. Has anyone tried the question? Has anyone tried the solution? Okay. In that case, we will just go to the solution. No one seems to have tried it. That's fine. So just to remind you, this is what we have to generate. We have to generate a Pascal's triangle up to arbitrary order. Of course, I have only shown up to 10 rows, but it can keep going. And the rule of a Pascal's triangle is you start with 1, 1, 1, and then every row starts and ends with 1. But all the elements in between, if you want to generate, you have to take the sum of the element right on the right, just of the right and top of it and the left and top of left and top of it, right and top of it. So for example, if I take this row, the fifth row, you can see that I start with 1, end with 1. To generate all the other elements, I have 1 plus 4 5, 4 plus 6 10, 6 plus 4 10, 4 plus 1 5. Okay, this is how Pascal's triangle is generated. So we have to write a code that generates Pascal's triangle up to arbitrary n. And I said bonus, try to print it in a triangle pattern, because if you just give print statement, it will print like a right angle triangle, right? It'll print 1 1 1. I want you to give the spacing. So I don't think any of you tried, so it's fine. I'll show you the solution. So So here is the solution. So essentially, this is the function which is going to help me to print Pascal, and this is n is the number of rows. So I'm going to give an array to store the generated Pascal triangle values. So here you have some array which is initialized to 0. So you can see that the array is a 2D array, right? It has x and y. That's because we want it to be the row and the column matters basically. Okay, so here you can see that we are iterating through every line and printing the integers in it. So we are going to for line in range of this. So first of all, we are printing this. So why is this line here? This is to ensure the spacing. So let's look at the spacing lines for last. Again, when I say spacing, I mean that if I want to print this in a triangle pattern, right? So let's look at the spacing lines last. Let's first look at how we are actually generating the numbers. Okay. So for number, every line has a number of integers equal to the line number. For example, here you have 1, here you have 2, here you have 3. Of course, it's offset by 1 because here the counting starts from 0, but you get what they mean. So if we go from every line in range of 0 to whatever the line number is, the first and last values of every row is 1. So we can first itself give that I is equal to 0 or I is equal to line, then array of line of I should be 1. Then we are printing it just like that. The other values are just the sum of the values just above and left of above, right? So for that, we are doing line minus 1, I minus 1. So that is just above, and line minus 1 and I, which is to the left, right? Because this is I minus 1 and I. So we are just summing up the top two values, and that will give me the line of I. So again, just to remind you, for example, here I have 1 plus 3 is 4, 3 plus 3 is 6, and so on. That is what is given here, and then we are printing. Now, the reason why I have these lines is because I want to ensure that it prints like a triangle. Okay, so I can show you first what happens if I don't have this line. Okay, let's just see what happens if I don't have this line. Let's give a 5 lines first. So you can see that it's just printing like this, right? I don't want it to print like this. I want there to be spacing. So then if I give this line, and the reason that it still seems to have some spacing is because actually when what did I do? Yeah, actually, when I'm printing, I'm giving the 6 spaces between so that it gives a spaced thing. The reason for that is that I want when I give this line additionally, it will actually spread it out so it looks like a proper triangle. Okay. So here you can see that I'm actually giving spaces into n minus line, because here, for example, I need to give, depending on how many rows there are, I should give the pattern. If there are only 5 rows, I only need to give 1, 2, 3, 4, 5 spaces in the first line, 1, 2, 3, 4 spaces in the next line, and so on. But if there are 10 rows, I have to give way more spaces in the first line. So that number of spaces is determined by n minus line, because of course when n is the line number itself, we don't have to give any spaces, because those that is the last line. Every other line you have to give n minus line number of spaces. So in the first row, that will have the maximum number of spaces, because there's just one number and we have to center that one number to the center. So that is the rationale behind this. So there are three lines which are ensuring the spaces. Basically, these end separation, these are all to ensure that the spacing is happening correctly. Okay. So let's just try to do it again now with the spacing code included. So I'm just going to clear this. If I now run and I enter 5 rows, you can see I actually get it in the form of a triangle. Similarly, if I enter 10 rows, I get it in the form of a big triangle. You can see that now the spacing has to be such that this is at the center. So we have to include way more spaces. That's why that n minus line thing is important. For example, here we only had to include this many spaces. I have made it even more broad, because later you will see that there are 2 digit, 3 digit numbers, and for that to be in the center, we actually need to give a very broad triangle. So I did a lot of experimenting to find this correct one, and this is how I got it. Okay, so this is about Pascal's triangle. Does anyone have any doubts or any questions about this? I think it's fairly straightforward program. The figuring out the Pascal triangle numbers is just a matter of using your array indexing properly. If you understand array indexing properly, then you will be able to do it. The bonus part which I gave of printing it in a triangle is something which is actually quite interesting. It's not so trivial as just giving a fixed number of spaces, because the number of spaces itself is depending on the number of rows. And to realize that is very important. It doesn't only depend on number of rows, but also it depends on the line number. Even if there are this many rows, the first row should have more spaces than the last row. So there are many ways in which you can get the spacing. Of course, this is just one way. There are also many ways to generate the Pascal's triangle. As I said, this is a triangle, or this is a pattern which has lots of mathematical properties. One important thing is that all of these are actually binomial coefficients of 1 plus x to the power of n. Okay. So for example, this is 1, because that's 1 plus 0 to the power of 1 plus x to the power of n being x to the power of 0. Then this is x 1 plus 2x plus x square, 1 plus 3x square plus 3x plus x cube. So these are binomial coefficients in the expansion of 1 plus x to the power n. So if you know that fact, you can use that to calculate the Pascal's triangle. As I said, this is also powers of 11. You can use that to calculate the various numbers. So if you know a little bit of maths, you can use all of those. So if you search for Pascal triangle programs on the internet, you will find lots of people doing it in lots of different ways. You can also use, as I said, combinatorics is also involved here. So I have just used the most basic property of Pascal's triangle, which is that each element is the sum of the element on top and the element to the right of it, right? Just on top and right of it, you can use that same fact and you can also calculate. Okay, fine. So this was the program that I had. These are all the programs I had detailed today. So since this is the last class, I just wanted to keep a few extra slides so that we can, as I said, I am not going to be conducting a separate revision sessions. Maybe some of the other PMRFs are. So just to be aware, if you all are not aware, I am one of the PMRF TAs. There are three of us, if I am not mistaken. We all have session at different time and different dates, and we all discuss. So you know maybe some of them have been planning for an extra session. I am not sure about that at all. You can check with the concerned TA about it. I am not conducting. This is my last session. So I just wanted to give a quick conclusion to this course. So yeah, first of all, thank you for joining for the last 12 weeks. I think in the very first class, there were more than 200 people, and now there is a few people, but whoever has joined, thank you so much for joining over the last 12 weeks. If you look at the course layout, what you will see is that these are all the things that you have, a selection of the things um, that you have seen during this course. And what is like really sticks out to me is that there is such a wide range or wide variety of programs that you have actually seen. So by now, if you have sincerely taken this course, you would have access to all these programs in your hand. And along with that, I made a quick count when I was preparing these slides over the weekend. We have solved more than 50 programs during these set of program solving lectures, problem solving lectures, along with many more MCQs, which I didn't count. So now you have a good what can I say, collection of programs in your hand. You have the programs which are discussed in your course, you have the programs which I solved with you in these problem solving lectures, you also have the programs which are assigned to you every week. So you should have good arsenal of programs, and please, keep those programs in a proper documented fashion. And I think between all these set of programs, you will find most of the problems that you will face in Python will be okay, I don't know why my internet is being, yeah, will be handled in one form or the other in any one of these programs. So please keep a view of that, right? So these are all the programs that you have. And as I kept, maybe I'll just share now that just to remind you, all the programs we have discussed and all the slides, recordings, everything is available on my website. So please, where's the thing? If you go to my website, you will see that there is this Google Drive link. And if you go to the Google Drive, you can find all the weeks along with all the Python files. Please make use of this. I have made the slides, made the Python programs for you guys every week. I have also solved it in the class. All the recordings of the class is also available on YouTube. So you can please go and take a look. So the point is that, what I wanted to say was that you have now a collection of wide variety of programs ranging from very simple programs to very complex and very complicated programs. So they have given you, I think this course has been structured in a very good way, where they have started from the basics and gone to even very specialized modules. It might be that some of those modules you'll never use again, but still it's a very good thing that you have that in the back of your mind, so that tomorrow if you face some issue, you know that that is still an option. So again, as I said, please collect all these programs, save them in a good location. So, and always comment, you can even comment on my programs, you can make comments, make nice documented programs, so that 1 year from now, 6 months from now, when you go and refer to those files, you still understand what's going on, right? That's very important. It's not important just to write a program, we should be able to convey what we are trying to do. So that's why I have included this slide in every one of my lectures. These are just some of the things that you can do so that you can become not only a good programmer but a very good programmer. And my takeaways for this course are basically the following. According to me, these are the takeaways for the course. Programming is just a tool. It's not a magic wand. It's not a, one solution serves all. It's a tool that you have to use, and you have to know how to use it. So every tool is as good or as useful only as the person who's actually making use of it. So, as I said before, if you want to print the numbers 1 to 100, you can sit and write 100 print statements, or you can write a loop. So the difference between both of those are programming. The difference is one is a bad programmer and one is a good programmer. So try to have that, that's an extreme example, but you will find a lot of people who are doing programming making similar kinds of things, where, there might be a very simple way to do something, and you have to make use of the fact that this is a computer where I can give it instructions and it can be used in a very powerful way. But again, computer cannot think for itself. I have to do the thinking. So programming is, writing the syntax is only one part of it. You have to also have the logic or the programming mindset, then only you can do it. And how to develop that programming logic? It's only by doing more and more programs, solving more and more problems. So as I said, programming languages may vary by syntax, but programming logic is universal. So now you know how to write Python programs. If you want to tomorrow write C programs or Fortran programs, the logic remains the same. It's just that your print might look a little different. Your hello world will look a little different. That's all. The advantage of having Python be your first language is Python is very powerful, well documented, and it has a lot of interesting user added modules. Learn to be curious when you do programming and when you learn something in general, and you can take advantage of the fact that Python is so well documented, and you can actually go and do deep dives on each one of these resources. And as I said, maintain good coding practices and documentation. Your future self will thank you. Please never be in a situation where you open a file and you don't even remember what it was supposed to do, right? Give nice variable names. Don't give just A, B, C, D, E, F kind of names. Try to give nice variable names as well. This is just the beginning of your journey. So, this is just a flavor for you. We have covered so many things, so you can't be an expert in everything, but whatever you find interesting, please be curious and go and read more about it. Try to do more programs, set problems for yourself, challenge yourself. You can learn for the exam, get your certificate and go. But Python is such a skill that whatever field you're in, it will there will be some way in which it factors. So as I said, I am from a physics background. I'm an astrophysicist. I use Python basically every day for various aspects of my research, including calculation, plotting, visualizing, even solving complicated mathematical equations. When I can't do it analytically, I do it on Python, right? So this is having Python as a skill is something that's transferable no matter where you end up. And just having programming language and logic in general in whatever language you prefer is a very good skill to have right now. So please be curious. The only way to be a better programmer is to be curious and to be interested. You should find it fun. You should not find it as a chore, then it won't be interesting to you. So I hope that you guys continue programming even after your exam and all those formalities are done. So, with that, I just want to thank you all for joining for the last 12 weeks. And yeah, this is just, I want to wish you a very happy coding journey from now on. Remember, using Python, you can do anything, including flying. Okay. So, thanks a lot, everyone, for joining. I think, yeah, this is my last class. I hope this was a useful class for all of you. And I hope that this added to your experience of the Python course and you had some useful inputs from attending these extra sessions. I know that your exam is roughly in a month or maybe later. As I said, I am an external person. I am here just to solve these programs for you and problems for you every week. But please feel free to mail me in between if you have any questions also. My mail ID is available on every slide that I have shared with you. I mean, the front page of every PPT that I've shared with you. Can mail me, and with if you have any doubts before the exam. I'm not conducting separately a revision session, but yeah, please feel free to get in touch. And if any of you are interested, you can talk about anything else. Okay. So with that, I think we can end the sessions for this course and this problem solving session. All the best for your exam. And I hope you continue on with programming and coding because it's a very, very lovely and useful skill. Okay. Yeah. Okay. Thanks, everyone. Thank you for your nice messages. And as I said, please feel free to message me or mail me if you have any doubts before the exam. Okay. Fine. Okay, guys. Bye, everyone. All the best for your exam.